Have you ever wondered how engineers can build a massive tunnel underneath the ocean while thousands of tons of water are sitting above it? How can they dig through the seabed without letting the ocean flood the tunnel? If you think you know the answer, share your opinion in the comments. And if you don't, stay with me, because we're going inside the entire process. First, engineers have to find the safest possible route. They can't simply start digging wherever they want. Survey vessels scan the ocean floor using advanced sonar equipment. These systems send signals into the seabed and collect information about the layers underneath. That information is then converted into a detailed three-dimensional map. Engineers can see where the seabed is soft, where the rock is strong, and where potential problems could exist. They compare different routes and choose a path that can support the enormous tunnel structure. But mapping the ocean floor isn't enough. Engineers also need to understand the geology deep beneath it. They study different layers of sediment and rock to determine exactly where the tunnel should pass. Once the route is selected, massive construction equipment arrives at the site. And one of the most impressive machines is the tunnel boring machine. This enormous machine has a huge rotating cutting head designed to break through solid rock. When the machine starts moving, its cutting head slowly begins destroying the rock in front of it. The excavated material is continuously removed while the machine keeps moving forward. Behind the cutting head, a perfectly circular tunnel begins to appear. But digging the hole is only the beginning. Engineers now have to turn that empty passage into a strong, sealed tunnel that can safely survive underground for years.
As the tunnel boring machine moves forward, the next major job begins directly behind it. Engineers have to build the tunnel walls almost immediately after the rock is removed. Huge prefabricated concrete segments are brought into position using powerful robotic arms. Each segment has to be placed with incredible precision. One small alignment problem could affect the entire tunnel section, so the machine and its guidance systems constantly monitor its position. Several concrete segments are joined together to create a complete circular ring. Then another ring is installed behind it, followed by another and another. Slowly, the empty passage transforms into a long, reinforced tunnel. But concrete alone isn't enough. Every connection between the segments has to be carefully sealed. Workers and specialized equipment inspect the joints and apply waterproofing systems designed to prevent water from reaching the tunnel interior. The waterproofing system becomes another important protective layer around the structure. In some designs, multiple systems work together so that even if moisture reaches one layer, it doesn't immediately enter the tunnel. And remember, this tunnel is located beneath a huge body of water. The surrounding ground and water create enormous pressure, so engineers have to constantly monitor what is happening around the construction zone. Advanced sensors can measure pressure, movement, and tiny changes in the structure. Engineers receive this information in real time and can adjust the construction process when necessary. Then comes one of the most important challenges, making sure the tunnel is properly sealed. Engineers carefully inspect the newly completed sections and look for possible weak points or water pathways. At the same time, the boring machine continues forward, so construction becomes a continuous cycle. Cut the rock, remove the material, install the structure, seal it, inspect it, and then move forward again. And eventually something incredible starts to appear. A complete tunnel stretching beneath the seabed, with the ocean still moving normally above it. Now the tunnel has a strong structure, but it's still far from finished. Engineers need to make the new section safer, stronger, and ready for people and vehicles. Additional structural supports are installed wherever they're needed, and the newly completed sections receive their waterproofing protection. Underneath the tunnel floor, drainage systems are also prepared to control any water that might enter the surrounding structure. Then engineers begin working on ventilation. Inside a long enclosed tunnel, fresh air has to be continuously circulated. Large ventilation ducts and powerful fans are installed along the tunnel. These systems are designed to move air through the passage and help control the atmosphere inside. Engineers test the airflow and make sure the system can operate effectively throughout the entire route. Safety systems are installed at the same time. Emergency communication equipment, lighting, monitoring sensors, and evacuation routes become part of the tunnel infrastructure. But how do engineers know that everything is working correctly? They test it. Sensors monitor the tunnel's structural condition. while engineers inspect the walls, joints, ventilation, and electrical systems. Sophisticated control rooms collect information from cameras and sensors positioned throughout the tunnel. Eventually, the tunnel reaches the point where it can be connected to land. The camera follows the completed underground passage until it reaches the coastline. There, massive construction equipment works on the entrance structure. Concrete walls, support structures, and roads are built around the tunnel entrance. The underground route is carefully connected to the surface road system. Then engineers repeat the process at the opposite end. The second entrance is connected to another coastal area, creating a continuous route beneath the ocean. And when you finally see the entire project in one cross-section, the scale becomes difficult to imagine. There are two land areas, a huge ocean above them, layers of seabed underneath, and a reinforced tunnel running safely through the ground below. But before anyone is allowed to drive through it, the entire system has to pass a serious final inspection. The tunnel is now physically complete, but engineers still can't simply open the gates. First, they need to test almost everything. A specialized inspection vehicle travels through the tunnel while engineers examine the concrete walls, lighting, sensors, and safety equipment. Every major system is checked before the tunnel can become operational. Structural monitoring systems test the tunnel's stability. Ventilation systems are activated. Communication equipment is checked. Emergency lighting and evacuation routes are inspected. Engineers can even run controlled emergency simulations to see how the safety systems respond. If a warning system activates, emergency lighting and communication systems need to respond quickly and reliably. A sophisticated control center monitors all of this information. Operators can see cameras from different parts of the tunnel and receive information from sensors measuring conditions inside the structure. And above the tunnel, something completely different is happening. Ships continue traveling across the ocean as they normally would. From the surface, most people might never realize that a huge transportation route exists beneath them. That's one of the most fascinating things about an underwater tunnel. You can have massive ships moving above the water while vehicles are traveling through a completely separate route below the seabed. But why build something this complicated in the first place? One major reason is transportation. A tunnel can connect two areas that are separated by water and create a shorter or more direct route. Instead of traveling around a large coastline or using a different crossing, vehicles can travel directly underneath the water. Of course, creating such a structure can take years of planning, engineering, and construction. Surveying, geological testing, boring, concrete installation, waterproofing, ventilation, and safety testing all have to work together. And after years of construction, the moment finally arrives. The first vehicles are ready to enter the tunnel. What was once just a line on an engineering map has now become a real underground transportation route. Now comes the moment everyone has been waiting for. The completed tunnel finally opens to traffic. Modern vehicles enter the entrance and begin traveling beneath the ocean. Inside, the environment looks completely different from the world above. Bright lights guide the road, ventilation systems operate overhead, and monitoring equipment constantly watches the tunnel's condition. As the vehicles move forward, the camera can reveal something that drivers normally can't see: the enormous engineering structure surrounding them. Beneath the seabed, reinforced concrete, waterproofing layers, and surrounding rock work together to protect the tunnel. And above that structure is the ocean. A massive amount of water may be directly above the seabed, yet inside the tunnel, drivers can travel normally. This works because the tunnel isn't simply sitting inside the ocean. It's engineered through carefully selected geological layers, surrounded by strong ground and protected by a specially designed structural lining and waterproofing systems. Meanwhile, ships continue passing across the surface. Life above the water continues normally, while an entirely different transportation system operates below. From an aerial view, the tunnel can look almost invisible. You might see nothing more than ocean and coastline. But underneath the seabed is a massive route connecting two distant areas. And when you look back at the entire construction process, the scale becomes even more impressive. Engineers first had to understand the ocean floor, then study the geology, select the safest route, excavate the rock, install concrete segments, seal the structure, add ventilation and safety systems, connect both entrances and safety systems, connect both entrances, and finally, test everything. So an underwater tunnel isn't simply